Hello, so I'm in room 123, your chemistry lab, doing a few very quick experiments that you can start to work out some ratios and so forth. And at least it's some real experiments, even if you don't get the opportunity to do them, which is very annoying, I know. So here's some copper sulfate. Copper sulfate is an ionic compound made of a copper ion and a sulfate ions. So the copper ion is the Cu2 one, the bracket Roman numeral 2, so it produces the 2 plus charged ion. The sulfate ion is the SO4 ion, and that of course has a double negative charge, so it's CuSO4. So far, so simple. But copper sulfate is a hydrated substance. By hydrated, it's got water molecules on it, and there's a fixed number of water molecules on hydrated compounds. And what the aim of this exercise is to use molar masses and so forth to work out how many water molecules there are for each formula unit of copper sulfate. So it's CuSO4 dot a number H2O, and we're going to work out a number, what that is. And it's a really simple thing to do. So here we have some copper sulfate, here we have a thing called a crucible. It's a bit dirty, but that doesn't really matter. It's terracotta, it's glazed, and the joy of this is you can heat it up as much as you want and it doesn't crack or shatter. And we're going to subject it to quite a bit of heat, and anything else might crack or shatter. So the first thing we do is we zero the balance, and we place the crucible on it. And then I let you see what that is. Okay, so it is, you can see it clearly there. Now I add exactly some copper sulfate. So that was 28.05 grams, and now I add this much copper sulfate, and it's not 28.05 grams anymore. It is that much. And what I do now is I take that off, and then I'm just going to heat it. And here we are wandering about the lab, and you can see, actually there's something from a previous lab which is boiling away the water to leave the citric acid and the sodium citrate. So that's going on as we speak. Now here, I'll put this on a seat and we'll be able to see what's going on here, I hope. Goodness me, what's that? Right. So here we have with this, we put it on a ring stand, and there's a pipe clay triangle there. Those clay bits there are exactly the same as the sort of smoking pipes from the 11th to the 19th century that I used to find on the banks of the River Thames at low tide. And I pop that in there, we have a look at it, and we see that it's a nice blue colour. What I'm going to do now is change this from the safety flame to, whoops, the wrong way around, to the heating flame. I'll let more oxygen into it so it burns more of the fuel instead of wasting it as I was, and we start to see what's going on there. It is heating it. Still heating it, and I don't want to drop the laptop on that, and you'll notice, I think, in a while, that it's not so blue anymore. It's going to turn white. You'll see it around the edges now, and eventually all of that's going to be white. And the reason for that is that hydrated copper sulfate, the CuSO4 H2O, is blue. It reflects blue, it absorbs others. But unhydrated CuSO4 with no water attached, that's different. That's white. That reflects all of the spectrum. And so that now is going to turn white as we watch. It's being a bit slow, but it will do it. You can fairly clearly see around the edges where the heat is greater, where the heat is able to reach the copper sulfate sample, it's quite nicely turning white. And what I'm going to do is let that heat so it's completely white. Once it's completely white, that means that all of the water, all of the H2O has gone away from the CuSO4xH2O, and it's now just CuSO4. And what we're going to do then is we'll measure the mass of the crucible when it's cooled down a bit, and measuring the mass of the crucible with the dehydrated copper sulfate, then we'll be able to get what the mass of the water was that left. And then we'll be able to use a bewildering concoction of ratios and algebraic whatsits in order to work out the number of water molecules that are attached to every copper sulfate formula unit in hydrated copper sulfate. So I'll give you a sheet with those results on it very soon. Bye.